Okay, now students, chalo. So now we discuss SHM, simple harmonic motion. Okay, now we discuss what simple harmonic motion, SHM. Now students, what is the meaning by simple harmonic motion? So in case of SHM, simple harmonic motion, restoring force is proportional to displacement, but restoring force is proportional to displacement, but in opposite direction of displacement. Okay, restoring force is proportional to displacement, but in opposite direction of displacement. Okay, that is the SHM. So students, what are the example of SHM, students? See, in the case of spring, okay, suppose with the spring block is attached, with the spring block of mass m is attached. Now when displacement of spring in downward direction, student, okay, so restoring force, suppose તમે આવી રીતના નીચે ડિસ્પ્લેસ કરો છો, when spring is released, તો spring ક્યાં મૂવ થશે? upward. So displacement is in downward direction, so that restoring force is in opposite direction. અને જેટલું તમે ડિસ્પ્લેસમેન્ટ કરાવશો સ્ટુડન્ટ્સ ડાઉનવર્ડમાં, એટલું જ એને restoring force ઉપર લાગે. So same like in the case of pendulum, suppose displacement in this direction, this is the direction of displacement, then when pendulum is released, then restoring force acting towards direction. So pendulum oscillates like that. Okay, so this is the restoring force in a pendulum. So always students, in case of SHM, force is directly proportional to displacement, but in opposite direction. But in which direction? In opposite direction. That's why here we placed minus. Okay, x equals to F proportional to minus x. Replacing proportional, here we placed k. Okay, replacing proportional, here we place k. F is equal to minus kx. What is k? K is known as spring constant. Okay, what is the meaning by k? K is known as spring constant. What is the unit of k? Unit of k is Newton per meter. What is the unit of k? Newton meter. Why? Because k is equals to F by x. K is equal to F by x. So what is its unit? Newton per meter. So now what is the dimensional formula for Newton? m1 L1 T minus 2 for meter L1. So m1 L0 T minus 2. m1 L0 T minus 2. Chalo, so what is the formula for restoring force? F equal to minus kx, where k is what? Spring constant. And what is the unit of k? Newton per meter. Chalo, now generally students, there are the two types of SHM. Two types of SHM means two types of simple harmonic motion. Two types of SHM means two types of simple harmonic motion. First is linear SHM and the second is angular SHM. Two types of simple harmonic motion, linear and angular. Okay, two types of simple harmonic motion and angular simple harmonic motion, linear and angular, two types of SHM. Students, see, linear SHM means what? See, in the case of linear harmonic motion is in a straight line. Suppose spring either moving like that or either moving like that, spring. And in the case of angular SHM, it moving in a circular path or a arc. Suppose a pendulum moving like that in the form of arc. Okay, so it is angular SHM. Spring perform. This is the example of. This is the spring is the oscillation of spring is linear SHM, and this is what? Angular SHM. First we discuss, students, linear SHM. Okay, this is the formula for linear SHM. Okay, for linear SHM we write what? F is equal to minus kx. If you want to write for angular SHM, means in which angle is formed or its path is in the form of arc, like a pendulum. Okay, આવશે આપણે આગળ pendulum performs angular SHM. So for angular SHM, what is the formula? In the place of see, in linear SHM force, so in angular SHM we know torque. Okay, in linear SHM force, in angular SHM torque. So for angular SHM torque, k as it is, and x, then we write theta, where theta is what? Angular displacement. Okay, here displacement, so here we take angular displacement. So torque is equals to minus k theta for angular SHM, and for linear SHM f equal to minus kx. But before we discuss the motion of spring, means linear SHM. After that angular SHM. But most of the part જે ચેપ્ટર છે એ શું છે? લિનિયર SHM જ છે. મતલબ મોસ્ટ ઓફ બધામાં સ્પ્રિંગ જ આવશે આપણે. ઓકે, ચલો, નાઉ next students we define some point definition, then we discuss equation. So now first we discuss mean position. Okay, first we discuss mean position. Now students, what is the meaning by mean position? Mean position means what? Point at which oscillation begins to start. જ્યાંથી oscillation start થાય, that is known as mean position. And students, all the distance are measured from mean position. Okay. Distance of object is measured from mean position. Now see students, suppose this is the spring. Okay, this is its initial position. Initial spring position. After that when spring is displaced in downward direction, then oscillation start. So this is initial position, students. So this is it's known as O, means its mean position. Okay, the distance are measured from mean position. So the distance of object is measured from mean position. Now students, next we discuss displacement. Displacement means what? Distance of SHO from either side of mean position. Distance of SHO. SHO means what, students? SHO means simple harmonic oscillator. Object which perform SHM is known as SHO, simple harmonic oscillator. Suppose spring perform SHM, spring perform simple harmonic motion. So spring is known as simple harmonic oscillator. Okay. So distance of object from either side of mean position distance of SHO means distance of simple harmonic oscillator from either side of mean position is known as displacement. Okay. Okay, suppose this is the spring. Now during the oscillator, suppose now after some time spring, this is its position. So students, this is known as its displacement x. Okay, sure. Now amplitude. Next we discuss amplitude. Now students, what is the meaning by amplitude? Amplitude means maximum displacement of SHO on either side of mean position. Okay, amplitude is a maximum displacement. Maximum displacement of SHO means a simple harmonic oscillator. Maximum displacement of SHO from either side of mean position. Okay, so see students, if spring is maximum, suppose અહીંયા સુધી જાય છે students, Okay, see, when suppose this is the initial position of spring, now spring is slightly displaced in downward direction, then release. So now spring is moving upward, this is its maximum position, પછી ત્યાંથી નીચે આવે છે. So students, this is known as its extreme position, this is known as its amplitude. After that it moving in a negative direction, downward direction, so it is minus a, then again 0. Okay, so maximum displacements, this is the maximum displacement, so this is known as A. Okay, so x means displacement, A is maximum displacement. Sure. So we discuss displacement, amplitude, mean position. Now we discuss equation of SHM. Okay, we discuss equation of SHM. Next we discuss, students, equation of SHM. So generally three equation of SHM: x equals to a sin omega t plus phi, a cos omega t plus phi, or we can write both a sin plus cos, એને પણ SHM કહેવાય. Okay, or x equals to a sin omega t plus phi and b cos omega t plus phi. Okay, and A is known as amplitude, omega angular frequency, 2 pi nu t time. Or what is phi, students? Phi is known as initial phase. So initial phase means what, students? Point about which oscillation becomes start, that is known as its initial phase. See students, in many cases આપણે શું કરીએ કે સ્પ્રિંગને થોડું ડિસ્પ્લેસ કરાવીને રિલીઝ કરી દે, તો ઇનિશિયલ ફેઝ 0 છે સ્ટુડન્ટ્સ. If spring is slightly displaced and released, then what is the initial phase? 0. But મતલબ ઓસિલેશન ઓલમોસ્ટ મીન પોઝિશનથી સ્ટાર્ટ થતા હોય, સ્લાઇટલી ડિસ્પ્લેસ એટલે એને શું બોલાય? ઓસિલેશન સ્ટાર્ટ ફ્રોમ મીન પોઝિશન. સો then initial phase is 0. But if oscillation start from extreme position, તમે એને સપોઝ એકદમ ડાઉનવર્ડમાં લઈ અને તમે રિલીઝ કરો, then initial phase is 3π/2. તમે એને ઉપર લઈ જઈ કમ્પ્રેસ કરીને રિલીઝ કરો, then π/2. Why? Because તમને ખબર હશે 0, π/2, pi. Okay, if spring is compressed if spring is stretched in maximum in a downward direction and then released, then initial phase is 3π/2. If spring is compressed and then released, then initial phase is π/2. Okay, so these are the known as initial this is known as initial phase કે જ્યાંથી એના oscillation start થાય. Okay. Now students, next next students, see what are the different form of SHM. First, see, generally it is either represented by a sin omega t, means generally oscillations start from mean position. Then we used, if oscillations start from mean position, means અહીંથી start થાય then we consider x equals to a sin omega t. Then we consider what? X equals to a sin omega t. Why sin, students? If oscillation are start from mean position, if oscillation start from mean position means 0, then why we take sin x equals to a sin omega t? Because આ ગ્રાફ કોનો છે સ્ટુડન્ટ? સાઇનનો. ઓકે, તમને ખબર સાઇન 0 0, સો સાઇન સ્ટાર્ટ ફ્રોમ 0. ઓકે, તો મતલબ આમાં શું થાય? સ્પ્રિંગ હોય, તમે સ્પ્રિંગને સ્લાઇટલી ડિસ્પ્લેસ કરો અને રિલીઝ કરો તો શું થશે? સ્પ્રિંગ મૂવિંગ ઇન અપવર્ડ ડિરેક્શન, દેન અપવર્ડ એટલે પહેલાં મેક્સિમમમાં જશે, એમ્પ્લિટ્યુડ a, then again moving in a downward direction, again its displacement 0, then in negative direction maximum, then again 0. So one oscillation complete. First it moving in upward direction, displacement maximum, then moving in a downward direction, again displacement becomes 0, in a negative direction maximum, and again becomes 0. Then it's one oscillation complete. Okay, so if like that, then we take x equals to a sin omega t. If x equals to minus a sin omega t, if x equals to minus a sin omega t, then sin means what? Oscillation start from 0, from mean position. Sin હોય એટલે ક્યાંથી ચાલુ થાય? From mean position. But minus है, so oscillation start in negative direction first. Okay, मतलब पहला स्प्रिंग क्या जैसे नेगेटिव में जैसे પછી 0 ना. If oscillation start from extreme point, તમને એમ કહે કે oscillation start from extreme position. Again માટે oscillation, if oscillation start from mean position, આમાં આવશે oscillation start from extreme position. See, oscillation start from extreme position. આવી રીતના oscillation starts from extreme position. Then we take, it is a graph of cos, students. Why? Because cos 0 1, cos 0 1. So if oscillation is start from extreme position, then we consider x equal to a cos omega t. Okay, so same, if oscillation start from extreme position and it is in negative direction, then we consider x equal to minus a cos omega t. Okay, so these are the 4 possibilities, students. Here these 2 equations are what? When oscillation start from mean position, then we use this 4. Okay, when oscillation start from mean position, and these are used when oscillation start from extreme position, means upward or downward. Okay, but see, students, તમને એમ કે oscillation start from mean position, then generally we take x equals to a sin omega t. And एम के oscillation start from extreme position, then we take, अगर specify करे कि oscillation start from extreme position in downward direction, then we take x equals to minus a cos omega t. ખાલી એટલું જ કહી કે oscillation start from extreme position, then we take x equal to a cos omega t. Oscillation start from mean position, then we take x equals to a sin omega t. અને બધામાં ડેરિવેશન આવશે હવે વેલોસિટી ઓફ SHO, એક્સલરેશન ઓફ SHO. So in that case students we take x equals to a sin omega t. ઓકે, ઘણા તમે રેફરન્સ બુક જોશો ને સ્ટુડન્ટ્સ, એમાં કંઈ મેન્શન ન કરે ઇક્વેશન ઓસિલેશન સ્ટાર્ટ ફ્રોમ મીન પોઝિશન, ઓસિલેશન સ્ટાર્ટ ફ્રોમ એક્સ્ટ્રીમ પોઝિશન, કંઈ મેન્શન ન કરે ને હવે રેફરન્સ બુક્સમાં, તો એ લોકો શું કરે કે એવું અઝ્યુમ કરે કે ઓસિલેશન સ્ટાર્ટ ફ્રોમ મીન પોઝિશન એટલે શું હશે, એક્સ ઇક્વલ ટુ શું લઈ લેશે, એ સાઇન ઓમેગા ટી. બટ નીટમાં જે MCQ પૂછાણા છે સ્ટુડન્ટ્સ એમાં મેન્શન કરેલું છે ઓસિલેશન સ્ટાર્ટ ફ્રોમ મીન ઓર એક્સ્ટ્રીમ પોઝિશન. ઓકે ચલો, સો એમાં તમારે કંઈ ચિંતા નથી કરવાની, એમાં તો કહેશે જ કે ઓસિલેશન સ્ટાર્ટ ફ્રોમ મીન પોઝિશન ઓર એક્સ્ટ્રીમ પોઝિશન, રાઈટ. બટ અગર કંઈ તમે કોઈ રેફરન્સ બુક જોશો તો એમાં મેન્શન નહીં કરેલું હોય ને તો એ લોકો એક્સ ઇક્વલ્સ ટુ એ સાઇન ઓમેગા ટી લેશે. મીન્સ એવું અઝમ્પશન હોય છે કે ઓસિલેશન સ્ટાર્ટ ફ્રોમ મીન પોઝિશન, મીન્સ એક્સ ઇક્વલ્સ ટુ એ સાઇન ઓમેગા ટી. Okay, and in the case of derivation we also used x equals to a sin omega t. Okay, chalo, now first after discuss velocity of SHO, velocity of simple harmonic oscillator. Velocity of simple harmonic oscillator. So, okay, see we derive the equation students, direct નથી લખતો because એમાં અમુક સ્ટેપ્સ એ તમને યુઝ થશે. Okay, so what is the equation of SHM? Equation of SHM is given by x equals to equation of SHM is given by x equals to a sin omega t. Okay, equation of SHM is given by x equals to a sin omega t. And then if we want to find velocity students, if you want to find velocity, then dx by dt okay, if you want to find velocity, then what, dx by dt. Now what is x students? X is a cos a sin omega t. A outside derivative of sin omega t. What is the derivative of sin omega t? Cos omega t into omega, right? This is the rule of derivative. Okay, multiply with the coefficient of t. In case of, it is known as chain rule, and in case of integration, divide by the coefficient of t. Okay, chalo, so here a cos omega t into omega multiply with the coefficient of t. Okay, and in case of integration student, in case of integration, divide by t. Chalo, so what is the velocity? Omega a cos omega t. What is the velocity? Omega a cos omega t. Chalo, done. Now we want to write students, see, now we want to write answer in the terms of displacement x. Okay, this is the equation in the terms of trigonometric function cos, but now we want to find v in terms of x. So see students, x equals to a sin omega t, but અહીંયા તો cos છે, so we want to convert cos into sin because x equals to a sin omega t, so we want to convert cos omega t into sin omega t. Chalo, so we know that one relation cos square theta plus sine square theta equal to 1. So cos square theta is equal to 1 minus sine square theta. So cos theta is equal to plus or minus, because when we take root then we take plus or minus. So students, here we write plus or minus 1 minus, okay, in place of cos theta. चलो, so now when we multiply a अगर रूट में जाए तो शू थी जाए स्टूडेंट्स a स्क्वेर. ओके, सपोज अंडर रूट में a स्क्वेर हो तो बार आए तो a थाय, तो रीतना a ने अगर तमारे रूट में एंटर करो हो तो a स्क्वेर. सो नाउ मल्टीप्लाई बाय a स्क्वेर. सो a स्क्वेर sin square omega t. Now see students, this a square sin square omega t means what? X square, because x equal to a sin omega t. So x square equal to what? A square sin square omega t. Why? Because x equals to a sin omega t. So students, a square sin square omega t is known as x square. So what is the velocity? Plus or minus omega under root a square minus s square. S square minus x square. Okay. Now see students, next what? Now we take different value of x. Suppose if we take x equals to a, so students remember this formula. This is the velocity of SHM, plus or minus omega under root a square minus x square. A is a maximum, a is a amplitude, maximum displacement, and x is a displacement. Omega angular frequency 2 pi nu or 2 pi by t. Now we take different case. Suppose if we take x equals to a, then what? Velocity equal to plus or minus omega. If we take x equals to a, then a square minus a square, then velocity becomes 0. If we take x equal to 0, then plus or minus omega, a square minus 0, then it what? Plus or minus omega a. And if we take x equals to minus a, then plus or minus omega. In the place of x, write minus a. So what is the minus a square? Means a square minus a square, then again 0. So it means what, students? See, at x equals to a and at x equals to minus a, what is the velocity? 0. Because x equals to a means what? Maximum displacement. હવે students એ maximum position એ પહોંચે એટલે અહીંયા stop થશે, so its velocity becomes 0, then again moving in a downward direction. So that why at highest position its velocity is 0, and ક્યારે velocity maximum છે? From x equals to 0. એનો મતલબ હવે when it's from x equal to 0 means mean position. When oscillator passes from mean position, its velocity is maximum. Okay, so what is the maximum velocity? Maximum velocity of SHO is what? Omega a. What is the maximum velocity? Omega a and it about from mean position. Okay, from mean position. Okay, so from mean position, its velocity, its maximum, and what is the maximum velocity? Omega a. Chalo, so we discussed the velocity. What is the velocity of SHM? SHO, omega a cos omega t in terms of x plus or minus a plus or minus omega under root a square minus x square. And what is the maximum velocity? Omega a. Okay, so three equation for velocity. Now same acceleration of SHO. Now we discuss what? Acceleration of SHO. Now we discuss acceleration of SHO, acceleration of simple harmonic oscillator, acceleration of simple harmonic oscillator. Now next students, what is the equation of displacement? X equal to a sine omega t, x equals to a sine omega t. X equals to what? A sine omega t. So we want to discuss now, we want to derive acceleration of SHO. So first velocity, because velocity acceleration means dv by dt. So first find velocity. Velocity means dx by dt. What is x? A sine omega t. A constant. A constant. Differentiation of sine omega t is what? Cos omega t into omega. Why into omega? Multiply with the coefficient of t. What is the coefficient of t? Omega. So multiply with the coefficient of t, that is what? Omega. Chalo. So what is the velocity? Omega a. Done. Now find acceleration. So acceleration is equals to dv by dt. Acceleration is equal to dv by dt. So what is velocity, students? What is velocity? Omega a cos omega t, omega a constant. What is the derivative of cos? Minus sine omega t into omega. Why into omega? Multiply with the coefficient of t. Okay, so into omega, omega into omega, omega square a sine omega. So what is a sine omega t? See, a sine omega t is what? X. Chalo, and this is the acceleration in terms of trigonometric function. Now in terms of x, so omega square x. Okay, because x equal to a sine omega t. Chalo, so this is the acceleration of SHM. What is the acceleration of SHM? Minus omega square x. Okay, what is the acceleration of SHO? Minus omega square x. So now again we take 3 case. When x equals to a, if we take x equals to a, then what? A is equal to minus omega square a. If we take x equals to 0, then if we take x equals to 0, then what is acceleration? 0. If we take x equals to minus a, then minus omega square minus a. So students, what is the maximum acceleration of SHO? Maximum acceleration of SHO, maximum acceleration of simple harmonic oscillator is what? Omega square a. What is maximum velocity? Omega a. What is maximum acceleration? Omega square a. તો આમાં થોડું કન્ફ્યુઝન ન થાય, ધ્યાન રાખજો. સી ઇન ધ ટર્મ્સ ઓફ એક્સલરેશન માઇનસ ઓમેગા સ્ક્વેર એક્સ. પછી કેવી રીતના યાદ રાખવાનું? ઇફ મેક્સિમમ એક્સલરેશન, so maximum displacement. What is maximum displacement? A. Okay, so maximum acceleration is omega square a and acceleration is minus omega square x. So okay, so this is the acceleration of this is what? Acceleration of SHO. Now students, next we want to draw the graph of displacement versus time, velocity versus time and acceleration versus time. Okay, next we want to draw the graph of velocity versus time, acceleration versus time and displacement versus time. Velocity, acceleration and displacement. Chalo, so first write all the formula. X equals to a sin omega t, then ano differentiation, then we get velocity. So velocity is equal to omega a cos omega t. See, velocity is equals to what? Omega a cos omega t. What is velocity? Omega a cos omega t. What is acceleration? Minus omega square a sin omega t. What is acceleration? Minus omega square a. Chalo. Okay, so these are the relation of x, v and a with the time. Chalo, so first we draw the graph of displacement versus time. Here we write x, here we write time. Suppose start what is the equation of displacement? X equals to a sin omega t. Okay, what is the equation of displacement? X equals to a sin omega t. So it means students, this graph is start from 0 because sin 0 sin no graph 0 thi start thai. So it is here 0. Chalo, now see students, here one cycle is complete, so this is t, this is t by 2, this is t, then it is 3t by 4. Okay, ખ્યાલ છે students કેવી રીતના આવે છે t by 2t? See here students, for one complete oscillation, what is the time? Capital T means what is the degree? 360. And see here sine is maximum, so sine is what is the maximum value of sine? 1 and it is for 90 degree. So here what is the angle? 90 degree. 90, 180, 270 and 360. So for 360 degree, what is the required time? Time period, capital T. For 90 degree, what is the time? So when we cross multiply, we get what? T by 4. Same for capital T. Here what is the angle? 180. So for 360, what is the time? Capital D. For 180, what is the time? So we get T by 2. Okay. We get here T by 4, here T by 2. Okay, so it is the what? Graph of displacement. Here maximum amplitude, here minimum amplitude, right? Sure. Now next students, we want to draw the graph of velocity versus time. Next we want to draw the graph of velocity versus time. Okay, so see velocity in the case in the term velocity is in the terms of cos, है ना? Velocity is in the terms of cos omega t students. So cos graph of cos is start from extreme position because cos 0 1. So cos is start from here. Done. And see, it is this is known as maximum. We know the coefficient of sine and cos is known as maximum. So what is the maximum velocity? Omega a. And here what is the maximum minimum velocity? Minus omega a. Means it is also maximum velocity but in negative x direction. Chalo, now last students, we draw the graph of acceleration versus time. Okay, in last it is what? Graph of acceleration versus time. Now students, see here minus omega square a sine omega t. So graph of sine is start from what? Again it is in acceleration, again it is sine. So graph of sine is start from 0 but it is minus a. So it moving in a negative. Why moving in a negative direction? Because minus sine omega t, here plus sine omega t, so it moving in upward direction, it moving in a downward direction. And here what is the what is the acceleration? That is minus omega square a, and that is plus omega square a. Okay, so these are the graph of displacement versus time, velocity versus time, and acceleration versus time. Now students, from this graph we can note 2 points. Chalo, what is the first note? What is the students? What is the phase difference between displacement and velocity for SHO? Displacement, phase difference between displacement and velocity. See, velocity start from 0, displacement start from 0, velocity start from maximum. So what is the phase difference? 90. Because displacement start from 0, velocity start from maximum. So what is the phase difference? 90. ઘણા નાઈથી જ ખબર પડી જાય, સાઇન કોસ કોઈ ચાલે. ઓકે, સો for SHM, phase difference between displacement and velocity is is 90. Chalo, now second, see what is the phase difference between displacement and acceleration. See, displacement and acceleration both start from 0, but displacement is moving in positive directions and acceleration moving in negative x direction. So what is the phase difference? 180. અહીંથી ખબર પડી જાય બંનેમાં sin. See here in both the equations, sin omega t, but here plus sin omega t, here minus sin omega t. So what is the phase difference? 180. So, and what is the phase difference? Phase difference between displacement and acceleration is 180. Okay, now students discuss MCQ. See what is the first MCQ. For SHM, maximum velocity is 10 meter per second. For SHM, what is the maximum velocity? 10 meter per second. And what is maximum acceleration? 3.14 meter per second square. Find time period. Okay, we want to find what? Time period. Chalo, now students, what is the formula for maximum velocity omega a? What is the formula for maximum acceleration omega square a? So now students, divide this equation because we know the maximum velocity and maximum acceleration. So we write both the equation. Now students, take ratio. So a cancel. So we find omega, and from omega we find time period. Okay, omega is equal to 2 pi by t. So take a ratio. So mx by vmax is equal to omega square a by omega. A cancel. What is the maximum acceleration? 3.14. What is maximum velocity? 10. 1 omega is left. Sorry, see students, here in the question maximum acceleration is 31.4, right? What is the maximum acceleration? 31.4. Maximum acceleration is 31.4. So 31.4 divided by 4, so 3.14. What is omega? 2 pi by t. 3.14, pi is 3.14, cancel. So what is the time period? 2 seconds. Okay, so what is the time period? 2 seconds. Now students, one question is in homework. For SHM, velocity is given by 4v square minus 25x square. Find time period. Okay, for SHM, velocity is what? 4v square equal to 25 minus x square. Then find time period. Try this question, students.